Fascinating. Um, Moving on, we'll open with a perspective from IBM, and Dr. Prashant Pradhan is here, who's the business head for Smarter Planet and Industry Solutions for IBM. Um, he runs it for India and South Asia with a portfolio covering analytics, smarter cities, and smarter commerce. Um, Dr. Prashant has a PhD in computer science from State University of New York, Stony Brook, and a degree in computer science, bachelor's degree in computer science from IIT Delhi as well. So please welcome Dr. Prashant.
Can I use?
Yeah, sure. That's not a problem.
Nothing here. Okay. Good. Oops. Okay, great. Thanks. Yeah. So, firstly, thank you all of you, ladies and gentlemen, for having me here. I'm gonna give a perspective which is predominantly shaped by our experience doing smarter cities projects globally, right, with different both developing as well as developed economies. So we've done close to about 1,000 projects worldwide, right, in smarter cities, and these span different continents, China, Brazil, United States, Africa, right. So we basically have some perspective based on all this on-ground work with different governments, different cities, and then our effort currently in India, of course, is to try and apply it to the Indian context and local priorities. So that's basically what I'm gonna cover, right? So one of the questions, as you know, because of the new government's announcement around 100 smarter cities and so on, there's been a lot of introspection in terms of what's the definition of a smarter city and so on. So in the Indian context, what we found sort of most useful is to really look at it more from the perspective of the outcome, right? So if it's a smart city, really it has to have an impact on the citizen eventually, right? Do they have better quality of life? Are they safer? Are they breathing cleaner air? Do they have access to water and energy in line with their demands and so forth? Because what tends to happen is, depending upon the vantage point you're coming from, technology, infrastructure, and so on, the definition tends to get clouded by a systems perspective of what a smart city is. Somebody will say it's about sensors and kind of hooking things together. Others will say it's about new infrastructure, new sewerage management systems and stuff like that. But really what helps is, if you take a very outcome or a citizen-centric perspective on the problem, more clarity emerges in terms of what kind of interventions are required. And technology happens to be one such intervention, which has to be combined with various other elements coming from other stakeholders. So that said, right, basically smarter cities are essentially designed to achieve a higher quality of life, basically for its citizens, right? Are they more prosperous, more healthy, and things of that nature. And basically they are characterized by utilizing their limited resources more effectively, right? No city has unlimited amounts of money or resources to really get to what their citizens really. So, for example, if Bangalore is dealing with a traffic issue or a water issue, right? It obviously has to be within the constraints of what the city can financially do. So really, smarter cities tend to use a variety of means: infrastructure, process, technology, and sometimes its own people, to really build solutions which attack those specific areas and do it efficiently. So it could mean something like utilizing energy and water more efficiently, or preventing crimes and disasters before they happen. All of kind of the issues with JNK, with Vishakhapatnam more recently, and earlier at Uttarakhand, right? Those are classic examples where the cities were fundamentally not prepared from a process and from a decision support perspective to handle, right, what happened. So reducing traffic congestion, improving citizens' access to services such as healthcare, and creating new job opportunities and so on. So really, if you look at what are the local priorities or local context in a given city, right, the interventions become clear, right, how you need to prioritize. So so fundamentally, this diagram at the bottom shows that any kind of intervention that we see generally spans three pillars, right? Infrastructure, process and planning, and people, right? So globally, whenever we've done these projects, some of the most successful projects have been where we've taken a holistic view of the problem, right? So for example, if you're addressing congestion, right, the answer is not necessarily to put up, let's say, a traffic command center, or just to build more roads. It's really also management on the demand side, right, by getting right information to the citizens at the right time, so that they can make more informed decisions about using public transport and avoiding congestion scenarios. I'll show you certain examples, right, later on to illustrate the point. But really, if you look at any significant problem that cities are handling today, the solution really lies in cutting across the planning and process piece, people, as well as infrastructure. And technology really, as you will see, tends to be the glue across them, right, that we can use often to create these solutions. So, in terms, I'll skip forward. India, the earlier speaker obviously made this point that India currently, we are seeing a scorching pace of urbanization, right? If you just look at the averages, on an average, we're going to have, over the next 2 decades, close to 30 people moving every minute from a rural area to an urban city. That's the rate at which we are urbanizing. And like the earlier speaker said, it's a good thing, right? Cities contribute, dominant part to the GDP of the economy. So it's all good, right? And people ought to move to cities. The challenge, of course, is that, there's a capacity building problem, right? And also, like I said, within the limited resources, what you do. So there are clearly economic as well as capacity building drivers, which are driving government's initiatives. So, the problem of rapid urbanization we've had for a while. It's just that, now we've articulated it and recognized it as an explicit initiative, right? And that's why, you start to hear so much about 100 smart cities and so on. So that's our sort of canvas. And again, if you look at the government's initiative a little bit more closely, right? I mean, in the popular press, you tend to hear more about, let's say, 100 smarter cities and so on. But really, the scope of the scope of the project is really broader, right? There are close to about 500 cities targeted for what is called urban renewal. 100 cities which are satellite towns of large cities, right, to be developed into tier 1 cities, right? And there's a small set of what is called heritage cities, like Varanasi and so on, where there are specific initiatives targeted to kind of protect and protect their heritage and develop more tourism and things of that nature. And then there is another set which is greenfield, right? This is basically the mega cities that are gonna show up along for example, the Delhi-Mumbai industrial corridor and so on. So there we have the luxury of a clean start, right? We'll do a physical as well as a digital master plan and develop everything from grounds up. So there's a luxury of getting a lot of things right from the get-go in greenfield. But as you can see, the predominant number of cities, we're not going to have that luxury, and we have to build upon, right, what are the existing constraints in terms of legacy processes, legacy infrastructure, and so on. So, having said that, I mentioned this point before that really, if you see the functional focus areas, they really span, three pillars, right? Infrastructure, city operations, planning and management, and people, right? And what I'm gonna do in the the next part of the presentation is really try and illustrate how solutions spanning these areas need to often come together to solve specific city issues. So having said that, I'm just gonna probably, I'm sorry, I'm not actually getting anything on my screen here, so having difficulties controlling this. If you give me a second. Okay, good. So I'm sorry. Oh, okay. Sorry. Let's uh, extend. Does this work? Let's see. Not really.
We need smart laptops.
You bet. Probably, yeah. I'll. Let me try this. Let me try this one. Let's move a bit closer so that I can control this from this. Just give me a second. I'll just draw upon a couple of examples, right? So let me. Thank you very much. I'm sorry for the trouble. Um, yes, I'm alright. Thank you very much. So so I'll illustrate, for example. Let me speak a little bit before I show. So I'll take traffic as an initial example, right? So earlier, in some of the more developed economies, the kind of interventions we've done on traffic have more to do with, for example, setting up traffic counting cameras, creating the transport management center for the entire city, and so on. But obviously, if you look at Bangalore, right, the issue is not really about so much, centralized process and management of traffic. It's really, a big issue is really there on the demand side. So I'll illustrate an example of work that we did in Africa, in Nairobi. Here we had a similar issue, not a whole lot of automation, right? But obviously traffic was a big issue. So, what we really ended up doing there, and again, as the earlier speaker alluded to, is really use data, right, as a friend. So what we did is we were trying to figure out that what kind of interventions will lead to, alleviating the city's traffic issue. And it could be infrastructure interventions, such as converting a roundabout into a I hope you guys can hear me. In that case, I don't have to plug this. Is that okay? Yeah. Okay, great. Thank you very much. Hey, I'm sorry? Oh, your recording is getting messed. So fundamentally, the issue we had was that first of all, we and as I was saying, they had a plethora of choices in terms of how they could address the city's traffic issue. One of them was, converting, for example, certain roundabouts, that become very choke points of congestion into which were more in terms of demand management, right, on the citizen side. So what you will see is that both kinds of initiatives, right, before you actually make a decision, of course, you have to have some sort of an evidence in terms of the intervention that you're doing. Is it going to really help, right? Is it going to actually alleviate the traffic? Because otherwise you end up spending a whole bunch of money without necessarily getting the outcome. I'm sure you can relate this to certain type of interventions that have been done in Bangalore, for example, on Outer Ring Road, right? There's been a lot of capex investment in terms of converting some such intersections into flyovers and so on. But if you are a citizen, I live in that area. Any of you, I think eGov's office is in that area. I'm sure you've recognized that it hasn't really led to a whole lot of improvement because of specific reasons in terms of how traffic flows. So my Nairobi example basically illustrates that for an actual city. Let me see if I have this here. Okay, not this. Just give me a second. Okay, good. So I'll just let this play while I speak, right? So fundamentally, in this case, we did what is called an agent-based simulation, right? So first of all, we needed to have the data about the city's traffic patterns, right? And we didn't have really a whole bunch of capex or the ability to really measure all of this traffic. So what we did is we used the data that was already available with the city through public transit. So a lot of the city buses that move around in this city, they are fitted with, for example, GPS equipment. So what we were able to do is to take these source destination pairs of how much delay you get when you travel between different parts of the city, right, during different times of the day. Using this, right, and an alternative way is also to give your citizens an app, right, which will just run in the background as they move around in the city and give you samples of what's happening on different paths, right, during different times of the day. So fundamentally, what I'm gonna just pause this for a bit. So fundamentally, what happened in Nairobi is that we were able to take this existing data from the public transport system, feed it back to there are algorithms that actually allow you to infer from these samples, right? What is the traffic matrix for the city, and then plug them into what's called an agent-based simulator. So to illustrate what I mean, so I'm sure you guys don't believe that the way people drive vehicles in the US is anywhere similar to how the auto drivers drive their autos in Bangalore, right? There's a difference. So what happens is that across different cities in different parts of the world, these driving patterns are different. So using an agent-based simulator allows you to localize the model to that particular city. So for example, technically speaking, an agent representing an auto driver is a greedy agent, right? They'll kind of fill in whatever space they can get, they'll violate lane discipline and so on. You can actually model this. So the dynamics of the city traffic become very different depending upon the nature of the agent. So we use that kind of fairly faithful simulation, and we were able to tell, for example, the city that certain interventions that they were actually planning, right, to convert roundabouts into intersections and so on, were not going to change the traffic pattern in the city because of other dependencies that you have across the traffic matrix. So the point is, it's a systems problem. It has to be solved globally for the city. You can't solve it for one intersection or one point in the city. So it illustrates the point that there is a need for the traffic congestion problem. Solving it for an existing brownfield city such as Bangalore, requires a degree of depth, right? It requires. So when we say use of technology, often, and this is more of a case in India I've seen, right? People mistakenly equate technology with technology infrastructure, like cameras, wires, sensors, and so on. Technology also means simulators like this, math and science problems which are more related to algorithms, operations research, and so on, right? So once you take that broader view of what technology means, right, it actually is a extremely essential element spanning all areas, right, including even policy definition as well as any kind of urban planning and so on. So if you broaden the interpretation of technology to also include algorithms and OR, then it's pretty pervasive across all sorts of different smart city interventions. So on the policy side, right, and I guess we missed this part. Let me just see if I can. A similar example on sort of setting policy, right? Let me see. Where are we on this? Yeah. So So in Nairobi, there's a specific pattern. There are paydays that the government has towards the end of the month. So what happens is traffic just goes completely out of whack, right, during that time. People have money to buy petrol, they'll take all their cars and go on vacation and all sorts of crazy stuff like that. So we one of the interventions we did, and if you missed the previous diagram, what it shows is we are then able to model different kinds of policy interventions, such as staggering the paydays over a month's time, right? And similarly, if you look at a city like Bangalore, right, there are, a lot of the traffic is contributed by, all of these people basically going to their offices, right? So there's an opportunity by keeping, let's say a certain time of the day as that, everybody will be working. You stagger, the movement of employees a certain way, right, in bulk, right, headed to specific destinations, and you can model what will be the impact based on the city's, roads and the traffic matrix, right? What's going to be the impact of these kind of policy changes? In Nairobi, they found without a single penny of additional capex investment, just by doing this policy intervention, they were actually able to elevate traffic significantly in this city. So hopefully this illustrates to you that the earlier point that I made about infrastructure, process, and people, the traffic congestion problem, for example, in a city like Bangalore, needs you to cut across all of these areas. So you do need, aggregate command and control for traffic. You need people to be actually taking more informed decisions based on the, data or information that you're giving them. And similarly, on the infrastructure side, yes, once you have some confidence based on data that a certain infrastructure intervention is going to help, right? Then you basically go ahead and build that infrastructure. But if you were doing any of these in a silo, chances are that, you'll continue to make investment and not get anywhere. So, hopefully that illustrates the point that, a lot of these are about, taking a systems view of the problem. And technology really is, kind of the backbone of how you will leverage data, right, to come up with intelligent decisions on how to get smarter. So that was one example, right? And then if you look at a similar, I'll illustrate another similar sort of point, and this is to do with some of the brownfield cities, such as, how much time do I have? 5 minutes. Okay. So I'll just illustrate this with a diagram rather than a video. So this graph actually shows the level of what is called fecal coliform, right? It's a measure of pollution, right, the municipal pollution in the river along the path of the river Ganga, right? So, and it's a logarithmic scale, by the way. So anytime it goes up, it's really bad, right? It's kind of a factor of 10, as you can see on the y-axis, right? So that peak there is Varanasi, no surprise, right? All of us know that the stretch from Allahabad, Kanpur, Varanasi is actually the most polluting part, right, in the river. So does the intervention have something to do with the river? Can you do anything in the river to actually take care of this? It's no. The answer is in the city. So it looks like a water resource problem. It's actually a smart city issue, right? Varanasi, 80% of the city is unsevered. It's a 100-year-old city, right? There are 3 drains in this area that I think contribute 80% of the what is called biological oxygen demand to that stretch of the river. So what's really happening, right? So you want to solve the problem for the river Ganga. You think, and when you talk about Varanasi and you see in the popular press, what are the kind of smart city interventions you hear about? Oh, it's about tourism, right? We'll do city Wi-Fi and we'll give people information about where they can buy good stuff. That's absolutely not, so that's an example of, a misguided intervention, right? So if you take the citizen outcome as the sort of, source of, what you're going to do to make a particular city a smarter city, in Varanasi you will have to attack, for example, the solid waste management problem. And I'm just trying to illustrate the issue to you. You've also heard from the government this whole discussion around improving sanitation by giving access to toilets, and there's a big ask for CSR, right, from companies like ours to actually put toilets in schools. So again, example of a localized intervention. When you actually put those toilets, right, you actually have to do something with the waste, right? And if you do not have an end-to-end model for what's the sanitation plan for the city, this thing is going to get unviable within a couple of months, right? Because all of that aggregated waste. To illustrate my point, I have mapped, this is I'm just a simple view of where schools are, right, near the Ganga basin in Varanasi. And this is kind of, the municipal sort of GIS map, which is illustrating that where are the existing and planned, sewerage lines. So the issue in Varanasi is not that you don't have enough sewage treatment plants. The problem is, because 80% of the city is unsevered, you cannot get the waste to the sewage treatment plants. Plus, there is a financial objective. The city currently does not have enough money to actually run or give power to those treatment plants. So, most of the waste is not getting there. And second, even if it got there, you didn't have the money to actually run it. So the point I'm trying to illustrate is that entire population into sensors, right? And that's more powerful than any kind of sensor you can put, right, in the road. So, in terms of the city really understanding that where it needs to focus its resources and time and money, right, getting all of this leveraging just what you have in citizens, right, is actually a very powerful way. So with that point, I'll conclude my presentation. If you have any questions, feel free to reach out. Thank you. Thanks.